Hi, I'm Heidi Schwartz, and this is my electrical engineering project and slash vehicle simulation using Arduino and Unreal Engine 5. Okay, so my original idea was a little bit more involved, but I'll talk about that later. But the final version of this is actually quite simple. If you can see him, this is Arlen. It's an Arduino Uno, and I have a 2-axis joystick with a Z-axis press button. If you look at my diagram, it's very simple. I have 2 LEDs, a red and a green, connected to pins 4 and 5, runs through a 220 ohms resistor. The joystick itself, the x-axis and the y-axis, they're returning values between 0 and 1025. I have them wired into the analog 0 and 1, whereas the Z-press is just a switch, and so that goes here straight to pin 2. So that's it. Now we'll look at the sketch. Okie dokie. So the sketch, I start by declaring my LEDs, my joystick pins, again analog 0 and 1, and pin 2 for the Z button. And I declare my variables to store their values in later. In setup, I just go ahead and set the pin modes on the LEDs to output, and set the pin modes for the X and Y to input. And the Z button input pull-up, it's going to use the internal pull-up resistor that's in the Arduino itself. And then it's going to try to establish contact. Basically, I don't want it to start just as soon as I plug it in, just start spamming, values out. So we'll scroll down to that, establish contact. So while the serial available is less than or equal to 0, so it's not receiving anything over serial, it's just going to be printing A regularly, and it's going to have that red light on and the green off. But as soon as Unreal transmits something to it, it's going to go ahead and enter the loop. It'll go ahead and turn its green light on and the red light off, and start reading the values from the sensor. So the joystick, again, analog reading from the X and Y pin, and I'm going to immediately map it to a smaller range of values. I don't need all that. It's just going to go from 0 to 100, and I'll, like in Unreal, I'll show what I do with that later. Right. So then I am going to go ahead and print these to serial. And I'm using these letter prefixes to allow Unreal to parse and understand the data that it's getting back. Again, I'll talk about that later, but it's just very simply printing these out. Yep, so that's it. I figured I could show a quick example of this just using the serial monitor in Arduino, the IDE. So it's just printing A. It's currently trying to establish contact, but anything will do. Send back character A, and now it's starting to send these values. So you'll notice that the value for D and E, which is the X and Y axis, is 49 and 50. They're not the same. That's because joysticks do have this dead zone where it could be a couple, so the original range 0 to 1025, like 500 or so, but it could be 512, it could be a little more or less. It's kind of uncertain. You could be getting different values for while it's just sitting at rest. Let's see if I 0, 99. So there is that dead zone, and I'll be taking care of that in Unreal. Okay, so here I am in Unreal, and you'll notice that I'm not using C++. This is simply, I just didn't have a lot of time. I only discovered this scholarship about a month ago, and I just wanted to be able to quickly prototype and pull things together and see the visual picture of things. Because I'm not very comfortable with Unreal's API yet, so it was easier for me. But I'm handling all of my serial communication in a blueprint that inherits from game mode. Another option was handling it in the level, but I thought it would be better to do it in the game mode because I knew I was going to have 2 levels, one for the menu and one for the actual game. And I wanted to establish connection in both so that I could show, at the menu, hey, you're connected, or hey, you're not connected. And let the user connect their controller at the menu if they'd like. So that's why I'm doing it here in game mode. So the first thing that I'm going to do is try to establish connection. And I'm using a really nice plugin called SerialCom that helps kind of abstract the whole low-level process for me. So all I really need to do is define my baud rate, which I've done, to match in my sketch, and the port that I'm using. If I'd had more time, I would have really liked to dynamically find ports. Unfortunately, I wasn't yet able to do that. I'd like to before I share this game, though. So if the serial port is opened successfully, it's going to save a reference to this port and go ahead and give that greeting. If you'll remember, the Arduino is waiting to get something before it starts broadcasting its data. So just quickly flush the serial port, read all the rest of the data there, and then send a value A out there. And if that's a success, it's going to connect. It'll go ahead and call Arduino connected, which is going to communicate to the widgets, really. They're the ones that are bound to that event, so they can update and tell the user successfully connected. Now every tick, it's going to try to process incoming strings. It's actually checking first to see if it's connected, so it's only going to process that data if it is. But what it does is it's going to read a line in from the port, and if it's successfully able to read a line, it's going to go ahead and start parsing. It wasn't always able to read lines because you can't. It's just sending data, and sometimes it reads, sometimes it doesn't. But this is where the prefixes that I added are coming in handy, because if you just send out the data, I tried doing first like storing all the incoming values in an array. I expect these 4 values, so the array was going to hold 4 values, and then I was just going to go through there and just, the first will be for the X, the second will be for the Y, right? That doesn't work out so well. It doesn't actually align to what you would think. So this is the way to do that. I know that ideally there's, I should be like on a lower level with this, using bit shifting, and but I'm really not that familiar with that yet. So I decided to keep it simple and use this. And I'm not having any performance issues with this setup, so here it is. If in the future I needed more inputs for whatever reason, or there was more going on, I know what I would do to make this more efficient would be to create some kind of a more efficient protocol that would be maybe using like on the byte level to determine what values are what. But as it is, it's parsing this, it's getting rid of the prefix, converting the string to float or int, and it's going to set these values for later. Okay. Okay. So we're gonna set a timer here just to regularly flush the serial. Basically there's like a whole backlog of inputs just because the rate of transfer from the Arduino to Unreal is so high that Unreal can't keep up with it every tick. So what ends up happening is I'm holding down the Z, for example, and it takes 4 seconds or so for Unreal to catch up through that backlog of inputs, and then to finally start registering and behaving the way it's supposed to. So regularly flushing the serial helps to keep things very quick. And then next, I am setting a timer here to run every 2 seconds. This is just to check if the connection is still active. So what's going on here is, if you'll recall that in the sketch, that final piece of data prefixed by C is just the number 1. But basically, I know that, well, by default, this is set to 0 here in Unreal. So I know that if it's set to 1, I'm getting something from the Arduino, right? So I just check to see if, is it equal to 0? If it is equal to 0, Arduino isn't writing. And so I've got a problem. And I'm going to start trying to reconnect. But before I get to that, we'll just say if I am getting something from Arduino and it's 1, it's just going to reset that connection string back to 0 to see if Arduino is going to continue to send me data and for that to be set. So in the case where I'm not getting anything from Arduino and this is still 0, then I'm going to start trying to reconnect. I'm going to let that timer run for, I decide 3 times. This is my max data loss. And each time I have no new data, I'm going to increment the failed data tries by 1. And so when this gets to over 3, I have 4 failures, then I'm going to go ahead and start trying to reconnect. Status is connected to false right away, and I'm going to attempt to reconnect. Okay, so when I call attempt to reconnect, I'm going to go ahead and attempt to reestablish the connection, call that function, and if that works, then we're going to reset the failed data tries, like how many times it's been trying to reconnect, and it's going to go ahead and call, hey, we're connected again. If it doesn't work, it's going to go ahead and start incrementing retries. So I have a max retries set to a pretty forgiving number, to be honest, here at 1,000. And so it's just going to check to see if it's retried that many times. And if it does hit that max retries, it's going to pause the timer so that it stops retrying. And it's going to call Arduino disconnected, which is going to completely, like, we're skipping that. And that has some effects, obviously, with the widgets, but also with the vehicle itself is no longer going to use Arduino inputs. Here. Oh, very important. When the game closes, the port needs to be closed. It's very simple. Just see if the serial port is valid, and if it is, it's going to go ahead and close the serial port. This is helpful for, if you close the game and you never close the port and then you reopen the game again, the port is like busy and it's not going to connect properly, basically. So I think that's basically it for serial communication. So I figured I would go ahead and demo how the Arduino handles disconnects. So I'm turning down the audio so it's hopefully not too loud. And I'll connect the Arduino. So see, the red light is on. And I'm going to go ahead and hit play. Oh, actually, I should go to the main menu first. Searching for Arduino device, Arduino connected. So we're good to go. Now, just move this over here. Okay. So let's say we're driving along and then for whatever reason, I'm gonna pull the plug. Let's do like here. Then when I reconnect, I can't move it. But when I reconnect, there we go, I'm back. I would say the only thing that would improve this is if I had a UI for the user so they could kind of see what was going on. Anyway. Whoops, that's what I wanted to. Okay, so here's the vehicle. And the parent class is wheeled vehicle pawn. It's a chaos vehicle. The movement comes from the vehicle movement component, which I'll talk about later. But the mesh, I modeled this in Blender. It's very simple. I wanted to keep everything simple and block-like. Modeled that in Blender and then painted the decals in Photoshop, did some texture painting in Blender, and then imported it to Unreal as a static mesh. I converted the static mesh to a skeletal mesh, and then I rigged and weighted the wheels so that we could get them to spin, a spinning animation. And then it was really from there, I think, just adding the giraffe. So I modeled the giraffe separately in Nomad because I actually sculpted it. And then I imported it, well, I texture painted in Blender, and then imported it to Unreal. And rigging him and getting his skin weights and the physics constraints was quite a task, but that being done, added him in here, and he's connected by a physics constraint component. That's really important so that he doesn't just fly off when you start moving. I got a spring arm and a camera here. That's only used for players who are using keyboard and gamepad, though. For Arduino, if you have the Arduino connected, I went ahead and decided to use like a bird's eye view and had those external cameras that are placed throughout the level. I just like that better. Oh, and I have a headlight. What's up? Okay. So when the vehicle player begins, it's just going to wait for a few seconds. This is partly to allow the quest to pop up. You got to get to your destination as fast as possible, but it's also to give a chance for the Arduino to connect. So it serves two purposes there. We're going to get the game mode, and we're going to see if we are connected to an Arduino, and if we are, we're going to set the vehicle to using Arduino. I'm gonna start calling it the truck. This is the truck. So if it is not using Arduino, that's okay, because I've actually set up an enhanced mapping context for this, so we can play it with the keyboard or the gamepad if you want. It's a lot of fun. So I've got that, but if the Arduino is connected, that's great too. I'm just gonna bind an event to Arduino disconnected so that if the Arduino is gone, we just can't get hold of it. The only input that's going to be allowed from the vehicle is this endgame Arduino input, which is basically just ending the game. So, okay, so the vehicle functionality comes from this vehicle movement component that I have given it. This is a wheeled vehicle pawn, so it's part of the chaos vehicle plugin. It's a lot of fun to set up and tweak, but I don't have to define the physics at a, like, I don't have to define them from scratch. So I have to set up my wheels, and do things like enable friction. I define my own torque curve. So I have over time how it ramps up, but then it ramps down. Max torque, max RPMs. Something that I had to mess with a lot to get this to feel right to me was the center of mass. If it was too high, it would tip over too easily, and then you couldn't get up. So I lowered it quite a bit, so that pretty much it'll always come back up, even if it falls over. I just thought that was more fun for the feel of the game. This isn't supposed to be a game where you can just get stuck and then what? Like, no. So that's pretty much it for initial setup. A lot of little values to mess with, setting the width of the chassis to equal the static mesh or the skeletal mesh, the width and height. Things like drag. Whether or not it was rear wheel drive or all-wheel drive. I thought all-wheel drive would be fun. Yeah. So, getting the inputs, I just defined some base functions that I could hook to both enhanced input actions for keyboard and gamepad, but also extend with the Arduino inputs that I was getting. So these base inputs, end game actually doesn't have anything to do with driving the vehicle. It's just when the game is ended, I want to be able to just, continue to the menu. But look, it's only available with the keyboard or the gamepad. Uses the controller yaw and pitch input. And this is where I'll start to talk about my original design. Originally, I wanted to have both a joystick controller on the Arduino and also a 6-axis accelerometer gyroscope, so that I could control the forward movement, backward, and the steering with the gyroscope. But I'll talk about that later. Here I'm setting up separate implementation of the handbrake logic because with the enhanced input action, it's really nice. There's a triggered and a completed, so that, when the input to brake is triggered, it sets it as true. When it's completed, when you lift off, it immediately will set it to false. Here I had to custom set that myself. So what I ended up doing was when that signal comes in, so it's a default 1, but then you press and it changes to 0. It's going to check to see if you are already handbraking, and you won't be, so it's going to run down here, and then it's going to check and see what your input is. So remember, off is 1. If you're pressing it, it's 0. So it's going to check and see, is it less than 1? Okay, true. Then okay, you are now handbraking. It's going to set that, and it'll set the handbraking input to the chaos vehicle movement component. But then what'll happen is it's continuing to sort of run every tick, right? So while you're still handbraking, it's going to check and see, all right, well, now is your input still less than 1? Is it still 0? And if it's not, which means you've let off your hand, then it'll go ahead and unset is handbraking, and it'll move on to the next piece of handbraking fun, which is for both of these, and it does end by ending the handbrake, but I decided to add a just this upward impulse this is just to help the player if they get stuck on terrain, basically. It's just a little, by oops force, the magnitude of 500. So handbrake, that's probably the most complex. The others are pretty straightforward because they're just going to take values in between. For example, steer is just values between -1 and 1. Look at the Arduino steer, for example. So if you'll recall, I mapped those values on the Arduino Sketch from 0 to 1025. I mapped those to 0 to 100 when they're sent to Unreal. So here I'm taking those 0 to 100 values and I'm mapping them again to -1 to 1. I wanted to do it on the sketch, but the map function only does integer mapping, like it'll just truncate the fractions, so it just doesn't work. -1 to 1. And it's going to add a dead zone. So basically, if the values are in that dead zone area, and so it's going to ignore that and just leave it at 0. It's not going to move. But otherwise, values closer to the -1 and closer to the +1 are going to steer us left and right. Brake and throttle are the Y components. And let's look at the Arduino. Again, there's a dead zone value. I didn't bother to map it because it doesn't really matter for me. It's either the throttle is either 1, it's either on or it's off. So really, I just wanted to know, okay, if it's less than 40, then it's okay. But if it's greater than 40, we're just gonna ignore it and just keep the throttle at 0. And the brake is the exact same. Oops, brake is the exact same thing. Except my dead zone value is 60. Is that all of them? Yeah, I think that's it. So handbrake, those. Not sure. So in the event tick, getting that forward speed. And if you're using Arduino, it's going to go ahead and use the Arduino implementations of those functions. If the game is ending, you're not allowed to do any of those braking and moving around. You can go to the menu if you want. That's it. Okay, so for the level, I have a note to myself just to remind me that it's the serial communication is managed in the game mode blueprint, not in here. So when we begin play in the level, I'm going to get the player controller and make sure that they can't use the game input right away. I don't want them to rush off before I've started the timer. And get my sounds going, and get a reference to the truck, the vehicle, and I'm going to play that quest widget. Then I'm going to start my timer, start gameplay. I have 2 cars that I spawn in just a kind of funny place. Just honestly, it's just because they look good spawn there. But I can't put them in a spawner because I don't want them to spawn right away. I wanted them to wait. So spawn my cars. I'm going to remove all those other widgets and set the input mode back to game so that the player can go. And we've got our countdown widget, the little ice cream bar in the corner with the countdown. Just add that to the viewport. So here I have my timer for the countdown timer that displays on the screen for the user, the little ice cream bar widget. It is going to run every millisecond and just be chipping away, decrementing the time remaining, which is initially 60 seconds. If less than 10 seconds remain, it's going to start doing some things differently. For example, the UI starts flashing. So it does take that Boolean just to check, and it'll update depending on that. I guess we can look at that really quick. Yeah, so it's just it will display the milliseconds, which is kind of the default with the float, so to 2 decimal places, and then it only displays the whole seconds while there are more than 10 seconds remaining. And all I do is truncate those values and give them to the widget. Yeah, the text is bound to this here, and so it's just setting that and updating that UI. So it does that, and also if there are less than 10 seconds remaining, it's going to check if the time remaining is less than 0. At that point, you've lost, right? To prevent the win event and the defeat event from firing at the same time, if you like run out of time just as you're speeding in, or I check to see if you're not already victorious. If you're not already victorious, then you're defeated. It's going to set that, and it's going to call that. But otherwise, you're going to begin animating the timer. So that's what's going on here. So if it's less than 10 seconds remaining, but we're not quite at 0, we're animating that flash to just indicate that time's running out. Almost the same thing on actor begin overlap with the trigger box where the final goal is. It's going to check to see if you're not already defeated, and if so, you're victorious. So it's going to take that vehicle and it's going to stop simulating physics on it, and it'll play the ending animation, which triggers all of the rest of the getting to the main menu and all of that. The final thing I have is just a little, like, if you manage to hit the ramp just right and get over outside the level somehow and you fall off the platform, I have a big trigger box down there to send you back to the main menu. Bad player. Actually, it's bad level design, but that's okay. My favorite part of the project was getting the serial communication working. There was a lot of trial and error, but getting it from just gobbledygook in my first serial monitor reading to getting that stream of Arduino consciousness into Unreal was a really glorious feeling. So I would say that was my favorite. My least favorite, ironically enough, is the giraffe. Now, I love the giraffe, like the end result, just looking at it. My favorite part about playing the game would be just watching that giraffe. It brings me joy. If I had the chance to start this project over, there are a lot of things that I would do differently. The biggest thing that comes to mind is I should always understand my inputs and outputs before starting to build something. The example of this being the MPU 6050, the accelerometer gyroscope. I did not understand what I was going to be getting back from this before I started. And it was really influenced by my design. I wanted that movement forward and backward and side and side. I didn't realize that it's not just like I'm not getting angles of rotation back, and that I would need to do quaternion math in order to get all of that working. And I got really caught up on it because I didn't start with it right away either. I only had a month and I didn't even have the components. So I ordered them, and while I was doing that, I was doing all of the coding and stuff, expecting those inputs. So by the time it got here, even then, I went through the whole hassle of soldering, getting inputs at all before I realized, wait, the inputs that I'm getting, I don't understand them, and I'm not going to be able to process them. Or I could have. Maybe I could have found a library that would do it for me. But I didn't like the idea of that. So I decided to scrap it, simplify the design, just use the joystick and get readings that I was familiar with. And so that introduced the new complexity of, okay, well, now I have to handle the camera, because if you just have the camera there, they're not going to see ahead of them. So I added those camera blends to give you kind of a bird's eye view. So, the more time that goes by, the better I understand that software engineering isn't just being able to code, it's being able to understand what needs to be built. And so if I had understood those inputs and outputs before getting started, that might have gone a little bit better. So live and learn. Secondly, having more math skills would be great. Like being able to do quaternion math and not freak out would, yeah. But I love that there's always more to learn. I mentioned this before, but another thing that I would do differently is do some more study and have a better understanding of the really low level communication and bit manipulation in order to have a more efficient communication protocol between the Arduino and Unreal. I feel like that could have been really cool to accomplish. And what I have works. I'm really happy with it. For this use case, everything worked out just fine. But, writing in C++ and shifting the bits around and kind of, understanding what you're getting based on the bytes that you're receiving would have been nice, but I'm not quite there yet, as you can see. The only other thing that I would change, really, I think, is maybe having a team to help me with some of the art stuff. So it was fun to do all the art and modeling and rigging and all of that, but having friends always helps. So on the next project, get some friends to help me out so I can focus on those other problems that I could have put more brain power towards. Despite this being a solo project, I did not do this entirely alone. The sound and music are in the Creative Commons licensing, but I'll put a link to that. I use the Serial.com plugin for Unreal to simplify the communication between the Arduino and the Unreal. My brother, I've got to give him a big shout out because he got the soldering iron to me through a snowstorm, and also told me to, quote, get good at the blender modeling. It was very problematic. And my dad also helped me out, gave me some tools for soldering. And then finally, my daughter, just a shout out because she watched so many Bluey episodes and gave me the time and space to work on this project. So thank you so much for your consideration for the scholarship and your time. I really enjoyed this project, and I hope that shows. So thank you so much.